Some of the trig integrals we are going to do will involve functions and their derivatives, such as sine. The derivative of sine is cosine. So I'm going to try and turn this into u to the third du. This is a u substitution. So if u equals sine of x, this would be sine to the third. Take the derivative of both sides. Du would be the derivative of sine is cosine of the same angle times the derivative of the angle. And I believe you have that here. So I have u to the third du. To integrate, I would raise to the 1 higher and divide by the 1 higher. So I end up with 1/4 u to the fourth plus c because it's an indefinite integral. And then I'm going to replace the u with what I let u equal, sine of x. Hopefully that one's fairly straightforward, just like the one below it. The derivative of tangent is secant squared. So I believe I have u to the fifth du. These integrals are set up fairly conveniently, because if I let u equal tangent of x, its derivative du, derivative of tangent, is secant squared of the same angle times the derivative of the angle. And again, I believe I have the du here. So it's just a matter of integrating, raising to the 1 higher, dividing by the 1 higher. That would equal 1/6 u to the sixth, again plus c because it's an indefinite integral. Then I will replace u with what I let u equal, tangent of x. Those again are fairly straightforward, conveniently set up integrals. If we look at ones like this, secant to the fifth tangent, you may have to realize that the derivative of tangent is secant squared. It's hard to get a secant squared. You could break it to secant to the third and secant squared. But the derivative of secant is secant tangent. I have a tangent, so if I pull off one of my secants, you do this fairly often when secant is raised to an odd power. If I pull off one secant, it would be secant to the fourth times secant. And then I believe I would have u to the fourth du. This time I'm letting u equal secant, and the u is secant because it's secant to the fourth. The derivative of secant, derivative of the left is du, derivative of secant is secant tangent of the same angle times the derivative of the angle, which again I believe we have. So I would raise it to the 1 higher and divide by the 1 higher, which would be 5. So this is equivalent to 1/5 u to the fifth plus c. This time u is secant of x. That one wasn't as straightforward because you had to pull a secant off. Now how about if you had tangent to the fourth? This is a difficult one. It could be broken up into tangent squared times tangent squared. Now I know that 1 plus tangent squared is equal to secant squared. So if I was to solve for tangent squared could be the same as secant squared minus 1. So I'm going to leave one of these tangent squareds. I'm going to change this tangent squared into secant squared minus 1, and then I'll distribute. This would be tangent squared secant squared minus tangent squared x dx. Now the derivative of tangent is secant squared, so this could be a u squared du. I don't know an integral of tangent squared. The derivative of tangent is secant squared. The derivative of secant is secant tangent. I don't have that. So I may have to do it one more time. I'll move this up a little bit. If I leave this first one, tangent squared of x, secant squared of x dx, leave that as a first integral. Then I'm going to call this tangent squared again, another secant squared minus 1. This is a u squared du, so I believe when I integrate it I'd have u to the 3 over 3, or 1/3 u to the 3rd. U in this case is tangent, because the derivative of tangent is secant squared. This one I could separate again, integral of secant squared. What is the integral of secant squared? Or I always say, because an integral is an antiderivative, what do you take the derivative of to get secant squared? And it happens that the derivative of tangent is secant squared. The integral of 1 dx is simply x. And now we've integrated a fairly complex trig integral, tangent to the 4th. I hope this helps. Some of these integrals are difficult. Good luck.